Hey everyone, today I'm having a look at the Corsair H100 PC water-cooling kit. This water-cooling kit fits all the latest sockets from Intel and AMD. It has a dual 120mm radiator, which means it fits two 120mm fans. Now for a quick look around the box, just pause it where you need to. So this is just saying it has Corsair Link digital support, which I'll talk more about shortly. Just some specifications here. So it's got the full dimensions of the radiator, including the thickness of 27mm, which is quite important. Also the speed of the fan, 1300 to 2600 RPM. The CFM of 46 to 92. The noise level is 22 to 39 decibels, and the static pressure is 1.6 to 7.7, which is very high. Just a bit more of a write-up on the back of the box. Performance times 2. This just means it's a dual 120mm radiator. Control at your fingertips. I'll show you what this means shortly. This is just comparing a stock CPU cooler to the Corsair H60, H80 and H100 on a Core i7-920 at 3.8 GHz at 100% load. This is actually not a very good representation of the Corsair H100 because it won't actually start to shine until higher overclocks than this, because of the size of the radiator. Now for a look at what's included in the package. So we have the product manual and installation guide, some information, the two 120mm fans, backplates, all the necessary screws, bolts, etc. A Corsair product catalogue, and the water cooling kit itself, which consists of a pump, heatsink, radiator, and also tubing and coolant. Alright, now for a close look at the water cooling kit itself. So the heatsink has the pump on top of it, and also all the controls and connections. So first of all, we'll have a look at the heatsink. So it's made out of copper. It has a brushed surface. Included is some thermal interface material. On the side here you can see this is where the tubing connects, and these 90-degree connectors rotate to allow for different cases and different setups. On top is a button and a display which allows you to control the RPM of 4 fans which you can plug into this unit. I'll talk more about this shortly once the system is up and running. So the 4 fans can be plugged in just here into these headers. 3-pin or 4-pin fans. Also there's another connector here for Corsair Link. Corsair Link can be purchased separately, and it comes with a hardware component and also software. It's for monitoring and controlling fan and pump RPMs from within the operating system, and also for monitoring temperatures. It also comes with an optional lighting unit, which is for controlling up to 33 LED strips, which you can install into your system. I'll be reviewing Corsair Link at a later date. Keep an eye out on my channel for that review. Okay, so for powering the pump and also the fans is a Molex connector. You can see there's only 2 pins. There's also a 3-pin header. This is for monitoring the pump RPM. You can plug this into any fan header on your motherboard, preferably the CPU fan header. The hold down brackets that are installed onto the unit by default are for all the Intel sockets, including socket LGA 2011, which doesn't come out until early 2012 at this point in time. So that's next generation Intel CPUs. If you want to install this onto an AMD socket, you'll just need to install the AMD hold down brackets, which are included. It's just a matter of removing 2 screws from either side of the unit. Now for a look at the radiator. So it's a 240mm radiator, which means it takes 2 120mm fans or 4 120mm fans in a push-pull configuration. The bolts are not included for a push-pull configuration though. It's designed to have the fans on one side and to be mounted to the case on the other side. But it does have mounts on both sides, you can see them here, and also on the other side, which could allow for a push-pull configuration if you're willing to go out and get the custom bolts. That would mean higher airflow for higher cooling performance. It has an extremely dense fin array. I'm not exactly sure what the fins per inch are because they're not included anywhere in the specifications, or I haven't seen them. It's quite a thin radiator compared to the custom offerings that are out there. It's 27mm thick. So just a look at the connections there. The diameter of the tubing is extremely small. The tubing is flexible, but it's fairly stiff, which is good. It's stable and it will stay in position nicely. Just to look at all the mounting components, so here we have a backplate which is for the Intel sockets. Here we have the hold down brackets for AMD. The Intel hold down brackets are actually already installed onto the unit by default. And here we have all the different nuts, bolts, screws, etc. for all the different sockets. Now for a look at one of the fans. So there's two fans included. They're 120mm by 25mm fans. So we had a quick look at the specifications before on the box. They're quite a high performance fan, that's for sure, which is exactly what is needed for such a dense fin array on a radiator. So there we go, they're a 3-pin fan. Alright, I'm just in the process of installing the fans onto the radiator. I've installed the backplate onto the motherboard. The heatsink is ready to be installed. Now you really need to install the fans onto the radiator before you install the water cooling system into the case. It makes it a lot easier. I've discovered something that's really shocked me. In all my years of water cooling and building custom systems, I've never punctured a radiator. This is something that I'm always extremely careful of. You know, you need to be there's a lot of things you need to watch out for when building a water cooling system, but this is one of the really obvious things. If your screws are too long when you're mounting fans onto the radiator, or you're mounting the radiator into the case, they will go through the mount and into the fins underneath, and they will puncture the fins. Okay, these screws are too long. If you have a look at the gap between the mount and the fins, it's about 3 to 4mm. And if you have a look at how much the screw hangs out just there, it's about probably 6 to 8mm, something like that. Because what this means is that it's going to puncture the radiator is going to leak, and it's going to destroy the entire water cooling system, and you're going to have to send it back, and you're going to get liquid on your hardware, which is a disaster. Okay, but I just done a little bit of research, and I found out that the fins where the screws, you know, on the sides here, they actually don't carry any fluid. They actually don't matter. They're really there for no reason at all. So it doesn't even matter if they get punctured. So it's fine. You can install these longer screws. You can actually install screws that go right through and out the other side. It doesn't even matter. I'm just surprised that it was designed like this, and you know, I feel bad installing screws that are actually going to damage the unit. Not that the damage actually matters. So I'm also surprised that no one has picked this up yet. Out of all the reviews that I've watched, no one has even bothered to check if the screws are too long. Alright, I have the water cooling system installed into my test bed. I'll just give you a look around and quickly go over the specifications. I have a Core i7 2600K, Asus Sabertooth P67, 8GB of G-Skill Ripjaws X, 78724 CR2 1.6 volts, 1600 MHz, MSI Twin Frozer 2 GTX 560 Ti. For the boot drive, I have a Corsair Force 3 60GB SSD, and I also have a Western Digital Black SATA 3 1TB. Power supply is an Animax Revolution 1250 watt, and the test bed is a Microcool Band Shadow 101. Now that I've got the system up and running, I'll give you a quick look at how this display works. So in the middle is a button, and this changes the speed, the RPM of the fans that are connected to the unit, which is up to 4 fans. So there's 3 presets. There's 3 fan RPM presets. When you press the button, changes the preset, and you can see this part of the display here lights up. So I've got the radiator sitting down here, just getting plenty of airflow, despite the fact that it might look like it's jammed up against the test bed. There's plenty of space behind it. I've just got the 4-pin Molex connected over here to an extension cable going to the power supply. I've got the 3-pin header for the pump RPM plugged into my CPU fan header on the motherboard. So 4 fans can be plugged into the unit. I've got the 2 fans plugged in at the moment that are on the radiator. The pump RPM for me is sitting around 2000 constantly. Okay, so these 3 presets are 1300 RPM, 2000 RPM and 2500 RPM, and the fan noise ranges from 22 to 39 decibels. So I'll just give you a listen to the fans now. It's at the lowest preset at 1300 RPM. Alright, so it's dead silent, I can't hear it at all. It's really drowned out by the 50 by 10mm fan I have running over here. So now I'm going to run the second preset. This is 2000 RPM. I'll just give you a quick listen. So it's just starting to become audible. It's not noisy though, at all. It's really just moderate, certainly easy to put up with, easy on the ears. Now for the third preset at 2500 RPM. Okay, so that's quite noisy. It's fairly hard on the ears. It's certainly a lot louder than any of the other systems that I've got running in this room. It is outside of a case, so that does make a difference. But at 2500 RPM on the highest preset, you are definitely going to hear this water cooling system. Okay, this is how I'm going to go about the testing. As always, I'm going to run Prime 95 large FFTs for 30 minutes per test. First of all, I'm going to run the CPU at stock clocks, and I'm going to run the water cooling kit on the low preset. Then I'm going to overclock the CPU to 4.6 GHz, 1.35 volts, and I'm going to run the water cooling kit on all 3 presets. Then I'm going to push the overclock as far as I can and give the Corsair H100 a run for its money. One thing that I need you to keep in mind during all of my testing is that I have an extremely high ambient temperature. My room temperature is very high, so I need you to only take into consideration the delta temperatures. The other temperatures mean nothing because they vary depending on the temperature where the testing is being carried out. Alright, Prime 95 has been running for 30 minutes, so there's the temperatures of all 4 cores. Okay, I've taken the core temperatures of 65, 69, 67 and 63, which gives an average core temperature of 66 degrees. The ambient temperature, the room temperature, is 33 degrees, so that gives a delta temperature of 33 degrees. Alright, so now what I've done is overclock the CPU to 4.6 GHz. The voltage is 1.35 volts, and Prime 95 has been running for 30 minutes. It's on the low preset at 1300 RPM. So there it is. There's the core temperatures. Okay, I've taken the core temperatures at 82, 87, 85 and 79, which gives an average core temperature of 83.25 degrees, minus the delta, which is now dropped by 1 degree to 32 degrees, equals a 51.25 degree delta. Okay, again, Prime 95 has been running for 30 minutes at 4.6 GHz, 1.35 volts. this time on the second preset. Okay, so that's what the cores are at the moment. The temperatures I've taken are 77, 84, 82 and 77 degrees on the cores. That comes to an average of 80 degrees minus the room temperature, which is actually now 34 degrees, is a delta of 46 degrees. Okay, this is the third test at 4.6 gigahertz, 1.35 volts. This time on the highest preset, as you can see and as you can hear. Prime 95 again has been running for 30 minutes. Just a quick look, and just a quick look at the temperatures across the cores. So the temperatures, the core temperatures that I've taken are 70, 78, 85, 81 and 78, which gives us an average of 80.25 degrees. Now something has drastically changed, and that is the room temperature. It's now 36 degrees in this room, which is very high. So that actually gives us a delta temperature of 44.25 degrees. Alright, now it's time to really see what this thing can do and push the overclock to the maximum. Okay, I tried to push the overclock as far as I could. The next step that I tried was 4.8 gigahertz, and with this particular motherboard and CPU, to increase the overclock over 4.6 gigahertz I need to substantially increase the voltage, which massively increases the heat output. So it failed at 4.8 gigahertz, it was going over 90 degrees. 4.7 gigahertz was still going over 85 degrees, so that was also a fail. So 4.6 gigahertz is the maximum overclock that I could get with this particular hardware, this platform, in this temperature, which, keep in mind, is very hot. Certainly other people will be able to go further in cooler ambient temperatures and with different hardware. I'm really impressed with what Corsair has done with this water cooling kit, particularly the larger radiator. Having a 240mm radiator means more overclocking headroom, and it means larger cooling capacity for more high-end hardware. Also, the display and the ability to control your fan RPMs, and the compact unit with the pump and the heatsink and the fan controller all in one. You can plug the fans into the actual heatsink. It's an excellent design. The aesthetics are great. Everything about it I'm very impressed with. Even the mounting mechanism, it's much improved over previous designs. I really have nothing negative to say about this water cooling kit. I do hope that in the future they bring out something more high-end though. Maybe a thicker 240mm radiator, or even better, a 360mm radiator. That sums up this video. Please subscribe and click like and favourite if you want to see more. Thanks everyone.